Hi and welcome to this channel. I have been developing a hobby operating system called SentientOS since the last more or less 1.5 years, and I wanted to start to share it and doing some coding videos. So let's get started right away. So let's quickly show to you what we're gonna do. So I've implemented this in Rust for the RISC-V architecture, and this is like a very primitive shell, but I can execute some programs. And what I want to do is like to implement the echo program. The echo program just simply writes out the arguments. The problem is I haven't implemented any arguments parsing or passing to programs. So that's what we're gonna do today, implementing the argument passing, and then the echo program should be pretty straightforward. So currently, how is a new program started? It happens via the sys execute syscall. This is like a macro I've written, which is doing passing the arguments to the kernel and validating the arguments in the kernel and stuff. So the sysexecute just receives a name of the other program and then returns either the PID or the sysexecute error, which is only invalid program or the name was not parsable. So what we need to do is to add another parameter here, which I will call args, and it will be a slice of strings. Um, yes, the error you're seeing here is because of the validation. As I already said, I have like a more or less complex validation or macro generation, basically because I want to, play with Rust. But let's see why this fails. So in the kernel, maybe look like that. The kernel implements the kernel syscall trait for every syscall, and we have a so-called arg wrapper type here, which is a wrapper around each argument. And the reason for that is that the user space could possibly pass invalid pointers, and we want to validate them before using them, and that's why we have this user space argument um, wrapper struct. And all the inner types have to implement ref2pointer. Ref2pointer is basically a trait which implements if we pass a value, it will be passed as a value. If we pass a reference, it will be converted to a const pointer, and a mutable reference will be converted to a mutable pointer. The reason for that is that we have to translate the pointers from the virtual address of the user space to the virtual address of the kernel. And in Rust, we cannot have references to invalid objects, basically. So we have to treat them as pointers, then translate the pointers, and then translate them back to the references. But this ref2pointer is implemented basically, yeah, for the reference types, but also for more complex types like this one. And the first thing we need to do is to do a ref2pointer for the type we just passed in. I'm not sure if this like works straightforward because we have to translate the pointers twice, one time for the outer and then for each of the inner elements. But let's see that. So what we're um, converting to is a so-called fat pointer. Pointer is just like a pointer and a length. Um, and actually, we're having reference to another fan pointer, which is basically um, like the inner fat pointer, which points to the strings itself, and the outer fat pointer just points to the slice. So let's say if that works. Oh no, we could do like a fat pointer just to a string. Although now we need some lifetime parameters. This might get ugly a bit. Let's see, can we do that and say they all have the same? Yes. And the fat pointer, is this implemented for the unstring? Yeah. Okay, I guess we first have to implement as fat pointer for the thingy we want to pass, and this will be the pointer to another fat pointer, which is U8. Sorry, this might be seeming a little bit, you know, utterly complex, and the reason is I've just implemented this a couple days ago, and I'm still not sure if I want to keep it, but I just wanted to play like with the validation being kind of automatic, but I haven't dealt with these more complex type. So that's why, yeah, we need to see if this works. But yeah, we will find out. I mean, this is like the fun of it. So, we already have that. That's right, like a generic implementation for that. So what is the issue here? Expected struct, fat pointer found struct. Okay, so this will be a pointer. Sure. And then I will be a pointer to a string slice. Okay. Seems good so far. Was that it? I'm not sure. Yeah, we have to implement it, but okay, let's like go a step back. This ref2 pointer has to be implemented in order to convert a reference to a pointer. We only did that already like for slice of U8, multiple and not multiple, and for string itself. But this is a new complex type, I would say, so we have to implement it for a slice of strings as well, and it will return a fat pointer, which is a pointer to the elements of a string. So let's see where the errors are. Exactly. So now every program we have, like I've split it this grade into kernel, common, and user space. And in user space, every program here is automatically basically compiled into the kernel so we can execute it. And these programs have access to all the syscalls. And because now we changed the method, we now need to pass in the correct parameters, and we will quickly do that. Like we will start just with an empty array and see if everything still works. So, okay. So let's see, does this compile? Probably not, because in the kernel, yeah, in the kernel, the syscall handler needs to need to also have the right method signature. So we have set it's like args, and it will be a user space argument of Lifetime mismatch. Okay, let's see what's going on. Let's compile it here so we have a little bit more space. These two types are declared with different lifetimes, but data from args flows into args here. So we need to, okay, let's do what the compiler tells us. Da, da, da. Yay! Just see if we can still run. Okay, perfect. The thing is we need to access it here. So you see, in order from a user space argument to get the inner type, we need to call the validate function. And this will probably not work yet because we need to implement the validation function by ourselves. Or maybe, okay, this is super cool, although I think it will not work. I show you why. So we have this validator here, which implements these validatable trait for the type we want to have. And it has a validate function. It's implemented on the user space argument, and it receives our syscall handler. The syscall handler is just a quick struct where we store the current process, the current PID, for example, and with the current process, we can access the page table and so on. So yeah, sometimes I need that, or mostly, so that's why it's there. And then it either returns the type T, which will be our slice of string slices, or an error, which is mostly the validation error. For example, this is um, for the network access. I've implemented UDP already, and it validates a UDP descriptor and either returns if the descriptor is valid or not. And now why this thing works is this monstrosity was implemented to automatically like work for AND string and U8 slices. And the thing why it works is that we only validate the outer pointer, like we only validate this outer thing here, this reference to see, oh, if we have a valid pointer, if it's like mapped in the page tables, and then we translate the pointer. So this will work, but probably not the inner string. So we need to implement like a special validation for the inner types as well. But let's see. So what we can do is sys execute called with args. So let's see if we can print the empty array. This should work because with an empty array, we don't have any inner elements. We only have the outer pointer. So let's try that out. And of course, it doesn't work. So it happens in the user space init program. The init program just like prints out init process, starting shell, and then we do the sysexecute command. But the sysexecute command didn't return correctly because we got an invalid pointer here. And I guess we came here, but returned on this question mark operator. And let's quickly validate that. Came here, exactly. Okay. So this validation function here will fail. And maybe we will attach a debugger or use the printf debugging. I'm struggling a bit. I will do the printf debugging, it's like slightly more convenient. So we're coming here, so we know we're there, and then we will basically log here. By the way, info logs will be printed always, but I also have like a debug log, and you can configure which modules are logged with the debug log, but I tend to use info while I'm like really debugging, because then I don't have to enable these print statements. And at the end, if I have some useful print statements, I turn them into debug statements. So yeah, I'm not sure if I can. Yes, exactly. The pointed thread should be clone, copy, and debug. Uh, should be working out of the box, because the pointer thread is basically implemented for star const t and star mut t, so they automatically implement debug, but they should actually not implement debug, but also pointer, because then I can just use the pointer thingies and then it works. So let's see what's coming out here. Okay, so before the validate, oh, okay, the start pointer is 0.8 and the second one is 3442. That doesn't, like, the 8 seems suspicious. This could be somewhere in the binary. So where is the issue here? Let's also like see for which type we are implementing that. So maybe he tries to validate first the inner one, but there should be not an inner one. So this is what makes me a little bit suspicious. So yeah, this is the type. I think they are out of order. Okay, let's see what's going on in this fat pointer stuff. So sorry. Where did I put that again? This is the pointer and the fat pointer stuff. So we didn't do anything here. Yeah, I see like ref to pointer. There it is in ref conversion. Right. So what do we actually want to do? Because is this correct? This seems like the equivalent. Actually, I haven't implemented this here. So what are we putting out here? We're putting out, it seems it's a fat pointer to just references only, but the toFat pointer thing will convert the inner thing as well. So maybe we should not use this toFat pointer thingies because yeah, they will turn the inner element to a star const. But what if the inner thing also implements as fat pointer? Like first like this, does this compile? Because yeah, we have conflicting implementations, and because the problem here is that this will be implemented for all the type T's, and this will be implemented for a subtype, and we are not allowed to have overlapping implementations. But because I'm using the nightly compiler, we could use this trick to make this only implemented for things of T which are not a fat pointer. Um, so let's see, we're doing the auto trade is plain pointer. This auto means here that this is automatically implemented for every type, and then we can opt out for all the fat pointer types and say this is not a plain pointer for T. And can we then say is plain pointer? No, not really, because um, maybe like this. Okay, you know what? It seems too complicated to do it like this. So we will ignore this toFat pointer and maybe come back later. But we will do fat pointer new, and it will receive a pointer which will be self as pointer and self.len. And okay, it re I mean, this was actually right, like or maybe not. Hmm. Ah, yeah. Let me think for a moment about this. Actually, let's just debug it. Let's just debug it. Maybe it also makes sense to just like put something here which we can recognize, and maybe even better, let's define that here so we can print out the the addresses of the elements so we can see more what's going on. Yes, exactly. And then we can use the arcs here. Mm, wonderful. And then let's go on a print journey. So we print the address of the arcs. We print the address of the first slice. Maybe also like should be the same, but just to make sure that bop, 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 feature slice pattern. Sure, we can enable that. Do I even need it now? We'll see later. So, maybe we should read the panic. Is this 98? Is this Okay, let's quickly check the output anyways. So init process started. This is the validator, the validator, the validator. Let's make like a sign so we know. And let's quickly implement this thingy here. So we will be converted back. Okay, wonderful. And see if we still get the error or if I was just like floating around for a couple of minutes without. Okay. So we can't read in the, yeah, okay, something is getting lost during conversation. And let's quickly, like, I don't know why do we get the validator while we, this is the validator of the output. Okay, let's quickly deactivate this logging message, otherwise it will be a little bit confusing. So we see the actual addresses of the slice, and then we can debug. Okay, so address of arcs, this seems it's on the stack. Wonderful. And this is the address of the actual value. So maybe I feel like this is easier, this one, the empty case, but maybe I'm wrong. Let's demystify that. Okay, so we have the address of arcs, and now we get index out of bounds because this thingy does not exist anymore. Okay, and then we go into the validation, and this is the slice from raw parts. That means maybe this is already on the way back. Like, I know I grew behind this pain by myself, and I hope it's still interesting for you. I feel like it's nice to have this validation if it works, but as I said, I've just implemented that recently, so okay. So I see we get the pointer of the element, but we have the length 0. And let's see to which pointer we translated that to. So I guess this pointer here is somehow not good. Um, this doesn't look really much aligned. And what are we doing here? Like, we are getting the page table, we're checking, is this a valid user space fat pointer? And then we translate this address to to our kernel address space. And we are here in the before validate, and this is the 7F. It's the same address we get from the output. So this is fine. And the len is 0. So what are we doing here? To ref if pointer, which function are we actually calling? Like, I assume, or I hope, this. Um, so yeah, what are the preconditions? This is a pointer to const and string. Yeah, sure. And so it is not aligned, but it's also not aligned here, right? Like, if we convert that to a pointer, ah, or is it because we don't have an element? So, because I feel like the null, the slice of a null, like a slice with 0 elements can be, like, the pointer doesn't have to be aligned. So the pointer is this an aligned pointer? Like, aligned by, I guess, 8. No. I mean, it's a very small number. Maybe I need to do these. Is it aligned? Hmm. Now I'm getting confused. We check if the pointer is aligned. So we get it from the ref conversion. So it is aligned here. So we could like recreate that by doing an unsafe slice from raw parts, and this is the pointer, and the length is len. And okay, so this am I like a little bit? This is definitely not aligned because it's 99, but this value is also 59. So this is not okay. Let me. Okay, we are failing here right now. Maybe we should like log what we're doing here, but we cannot log in the common crate. Mm -hmm. What is this check-in? Aligned to the type that we're creating. Maybe I feel like I've got these two indirections wrong a bit. Although like everything seems right and the address also seems like maybe I need to Google Rust slice alignment. Like hmm. Yeah, sure. Do they talk about the alignment? Should we do something easier? How? Actually, this should, like, I want it to work, but I feel like this is destroying something. Let's try do it ourselves and see if we get a different result. But I definitely have to simplify this thing a bit. No, our pointer is still not aligned. But is it already aligned here? This is the big question. 105, which is shit. Okay. Who calls to pointer if ref? I think this happens in the validator. So we create that. Ah, or maybe not. So while we are creating the user space argument, we are already converting that to a fat pointer. That means we can, I don't know, let's print that like it should be a pointer, so we should be able to print that. Yeah, we don't implement debug. So fat pointer, we can also derive debug here easily. So check again. We got this value, and this is the same value we got on the from the user space. So this is fine. Then we are validating this, and this one was it aligned? It was not aligned either. So like we cannot create from. Okay, I'm very sorry about that, that I'm kind of blind here right now. Shouldn't be that hard, but yeah, I guess being on camera right now makes my brain a little bit foggy. Address of arc. So this is the address of arcs, and this is already the slice. Ah, because this is already a fat pointer. We need to pass like the oh, okay. The thing we're getting here, I think it's the inner well, hmm. No, it's the address of the slice on the stack. So mhm. I think this gives me the first element. Sure. So that's not correct. What does slice as pointer do? Returns a raw pointer to the slice buffer. Oh, okay. And I mean, this is somehow correct. So we just have a fat pointer which contains, yeah, strings basically. So it's already, so we have a pointer to the buffer. And we kind of need to translate every element in that. Okay, how do I do it with that? Like I'm also pointing to the buffer, which is, I mean, fine here. And slice from raw ports. Hmm, hmm, hmm. But it seems like, yeah, I think I need to write a specialization of this function because we need to validate all the inner elements. So basically, hmm, oh, oopsie. Yeah, I never had this problem before because the inner type of the slice was always like direct accessible. Like what I'm actually passing here should be like again a user space argument in here so we can translate it. But the thing is, how should I like describe that here in my syscall interface? It should be work kind of automatically, but that's, I'm not sure how if this is easy to implement. Hmm. Because what are we doing in our definition macro? We have the R grabber and T has to be a ref to pointer object. So maybe we convert the inner type to something, right? So we should be able to override that ref conversion and do it to another type, like say this is also the ref to pointer. And we have the ref to pointer for the inner value, right? We have it here. So the out type is different because we need to do self like iter map to fat pointer Not sure if this will work right, but I hope you can still follow me. Like, now we get an iterator. Like, we're consuming the slice and we are returning an actual object, but we need to allocate it somewhere. I mean, the thing is, the compiler stores this fat pointers also as a length and a pointer, but this is not like it's not. Um, it can change in the future. That's why it might be difficult. Like we cannot do that. So okay, this is like one of the issues. Like we need to translate here also the inner references to pointers. Like what we basically want to do is like like this. Because fat pointer is basically a representation of a slice. So we want to do a fat pointer to like yeah. And so can we just do like and say this is also a pointer to fat pointer. It should take up the same like we now take an inner pointer, like we take the inner pointer to expected found raw const string. I mean, okay. We're doing the ref conversion and we're free to choose whatever we want to store as the out type. So can we just, you know, box it? Because, you know, the slice is in memory, but we want to kind of, we need some vec or something to store this. And so that the validator, and we implement that not for fat pointer, we implement that for like a, oh, could we do like a new type? So we're don't doing the fat pointer, we're doing the, how should we call this? Like a double fat pointer? Um, like a double slice pointer. Why do I use the fat pointers? Because I don't want to like have references lying around. So I just need to convert those into can we do, it's a vec of fat pointers which point to and of course we need to use extern alloc. No, what is it called? Not on the heap, somewhere. Extern create alloc. And then we can use. I should have made a little bit more thought about this before. I thought it would be easier, but yeah. And now we can do like self punct iter punct map. Each element will be to pointer if ref, and then we can collect that. We have to do that. Do it easy, Maurice. We will have a fat pointer new, like, no, we can just dereference one and then say e punct to fat pointer. Voila. And if we receive that vec of fat pointers, like we kind of need to convert that back. Is it so good if we store a vector? I mean, I need to store fat pointers. How do I do two versions of the fat pointer? Fat pointer pointing to another fat pointer, but where do I allocate? Do I need to allocate them? I think so, because here I'm just like creating a value. And here I need to somehow store these things. And who calls to ref if pointer? It was the validator, right? Let's keep that not implemented yet. I will quickly turn on the light. It gets dark in here. Sure. It says we didn't implement that for the we can copy that and then we adjust as our needs and maybe we can get them into one, but we say, okay, we have ref2 pointer and this is actually like a vec to fat pointers. And actually, like, let's keep it super simple and just say impl validatable for a user space argument of type and string validatable. This is what we produce. We produce the same conflicting. Ugh, damn it. I should never have like put that into one. Conflicting implementations. maybe I will just remove this mess of generics, which just for me to try it out, but I feel like it just makes it more complicated right now. So let's do them. I think like yesterday, we can just undo a commit. It was SMP, no, it was before syscall. I think it was this where, yeah, but I did a lot of things more, but maybe we can extract this thing here. Yeah, let's just implement them by ourselves. So if we have a single string, we can say, okay, we return a string. Yeah, sometimes it doesn't feel good to be overly clever, like, or at least it's not good. Like, as you can see right now, it just makes more problems for like, I would have need 4 or 5 validation implementation here and it should be fine. So we're doing string from raw parts and we have pointer and length. Now it complains that we don't have it for this or sys execute for just a buffer. Maybe we can unify it at the end, but let's see just how it looks like if we do it like this manually. I'm hoping you're not bored so far and it's still a little bit interesting. Um, yeah. As you can see, the code stays mostly the same. That's why I wanted to like do it more you know, automatically. But yeah, has not worked. And for the, do I need mutable? I think I don't even need mutable. Somehow I lost my terminal window. Let's quickly redo it. Yeah, there it is back. Okay. Yeah, this is the thing we're going to implement. Ah, we have a mute. Okay. My bad. Should be easy. We're doing this and we're just doing it for the mutable struct. And then we can do from raw parts mut. This will be the thing. Oh yeah, this is not. Can we compile? The bug you saw here is, yeah, we need to, I will commit that later in the user space cargo toml. We need to disable like the tests for every binary we have. And I just created a stress binary recently, so I forget. Now it's gone. Yeah. So we can compile, we can run, I guess. And okay, Now we can do like a better job by implementing this correctly. Sys exit, no, sys execute. And yeah, we have to implement that function for the thingy we want to pass, like dum dum dum. And this is also wait, like this vec I'm creating there. Does this happen in user space? Because then I just moved the problem. Like I would need to translate the vec as well. Hmm. You know what? We're doing it completely different. I feel like this is utterly complicated right now, and I have to think about that more through. I'm very sorry that I couldn't do that here right now, but it seems I have a knot in my brain and I have to rethink about it. But we will still implement that. I will continue in a new video, I guess, because some people just want to see maybe how we implement it correctly. But actually, we can do that now. Let's do that now. Um, I'm very sorry. We will just undo everything, although I can quickly fix this for the stress binary. This was just for me to and then we can make a new branch like use arguments, no, pass arguments to processes, pass arguments to sysexec. And you know what? We're doing this the easy way. So what we're gonna do is we're gonna say there is like sys execute at argument. So you can add just an argument one after another because this already works. Um, and why are we showing an error here? Unexpected token in the input. The return type is missing. This will already always be like fine. And maybe we need a sys execute arc clear method to, you know, clear the state. I know this is not a very ergonomic API, but it will work for this video. And then I guess I will do another video when we fix that mess. So let's directly implement that in the kernel. So we have these thingies here at the end of the method. And Where are we storing this? Well, we store it in the process. So we have a process here, and this will get just a vec like a sysexec args, a vec of strings. And we initialize that to an empty vec, as well as here. And then we can just, you know, actually we need to return value because we need to validate this arg and this must be successful or not. So we will use the validation error simply and pass back a result of either nothing or validation error. So yeah, regarding the pointers of pointers, yeah, I will come back to you guys. I hope you guys are not disappointed now that we're doing it this like simple way, but um, yes, we need to use the validate function, pass in self, which is the handler. And now we have the arg, and now we can just do self current process log. And we need a method to add the args. Will be self mutable. Yeah, I need it as a string, so let's keep it for that. Sysexec args, I have called that. Then we need like a clear function, which doesn't receive anything. And we need to like get them, which returns like this. Ah, mm, I'm sorry, I don't think I need this. How do I read? Am I? Can I just? Yeah, let's. Okay, so we have these functions. So now we can say log at sysexec arg, and we do arg to string. We need to import that because yeah, my LSP doesn't know about these alloc um, imports. So put that to a string. To clear, we will say the self, current progress, log. And I guess I will just like, yeah, I will never clear them automatically. And with that, we can, I guess, already edit our shell. So the shell is passing the argument. So what the shell is doing is we have a loop, we read a line, and then we execute that line. And we match this command And if we have nothing, we do nothing. If we have exit, we exit the shell. If we have help, we print all the programs and some help information. And this is if we want to like execute a command. But here we need to process arguments, I guess. And we will have like let split is gleich s equals command split, and we split it with a space. So we have can I collect them to a bag of sorry about that nonsense. So let's see. Now we have split, and we know that the first element, there is at least an element, and that these are like is the program name. And then for arg in split.iter.skip1, we can say sys execute at arg, and we are adding this, and we expect this to succeed. Okay, this worked fine. And let's say if that works. And to just test that, we're going to the sysexec. Oh yeah, and before we're doing that, we're doing a sys execute arg clear, because yeah, if we execute it twice, we want to have like a free arg array. So, and then we will just print it out here. Got args, and we do self current process log get. Why doesn't my auto completion work? How did we call that? Gets this. Fuck. Sorry. Gets this exec arc. Because we didn't have the info. Do that as a debug. And then see if we can put that. This was actually, I thought I would do that in the first 20 minutes, but yeah. Okay, so we first got arg0. If we do proc1, got arg0. If we proc1, okay, proc1 got 3 arguments. Okay, very nice. So we have the arguments here, and we need to pass it to start program. So we will do args like this. And we will pass the args from the current process log. I will be lazy. I want to have them here. I want to like, otherwise it would be problematic with, we have to keep the log, and I'm not sure Can we keep the log while we are getting the scheduler? No, actually, I think we can. Like, yeah, let's do that. Right. So we can current process with log. This is the current process. And we, for the args, ist gleich p.get sysexec arg. This should be called args. And then we can do that. How do I, like, I'm a little bit sorry. RAS convert vec of string to slice of string. The sref. I see what the problem is. So we would do this here as ref. And then we can loop through them. I mean, what do you want from me? You know what? We're changing this implementation anyways, and I think the problem is that we have it as a string inside, so need to add string here. So we have the start program, we have the args. If we find the program, then so now we have to put the strings on, I guess, the stack. Or we also add another syscall. Okay, because this video is like already going for a long time, I will do the a little bit more ugly way, but yeah, we will reuse this array for the next process and store the exec args here. So what we're gonna do is we have this process, very nice, and then we do process. We get a mutable reference, or actually we can do for arg in args process.add sysexec arg. Need to clone that string. Must to be mutable. Okay, so the next process has the args which has been passed to him, but now it needs to access these args, and we need to like do execute number of args. We'll give it a usize and sys execute get arg, and we pass in index. I know this is not very nice, But let's try that. And we need to, yeah, the caller needs to like allocate space for that. So we either say it's okay, or you will have a sysarg error, which could be invalid index, a validation error, or space too small. I want to improve that, but that's for another time. Yeah, this macro just implements the conversion of the validation error into that sysarg error type. So, okay, get arg, we are doing that, and it's either this or sysarg error. And we need a name for that. Okay, let's implement it in the syscall handler. First, number of args is self, current process, log, get sysexec args punkt len. And here we need to check like if we have this index, so we can do self current process with log. We have the current process. Actually, let's validate this buffer first. Then we need to check if we have this index. So ist gleich p get arg sysarg exec punkt get, yes, I get an option, so we have the index. And we dereference the index. The index is just the usize, so the arg wrapper just like gives it through. If let some arg do this, otherwise return the error sysarg error invalid index. Now we know the length of the like let bytes arg to bytes. Is it bytes? It's as bytes. Yeah. If bytes smaller than arg, we will return the error. Otherwise, we will do arg punkt how do I copy one slice to another? Clone from slice. Yep. Clone. Uh, is it because I don't have an... Why? So they have a mood. We have this mood. Clone from slice. Do I need to import it? Like on a slice. Uh, um, it should be there when T is cloned. Source must be the same. I think I have a like convenience method for that. It's something in the loader. I think it's just pages. Wait, I have the data. Oh, copy slice. Copy from slice. Why? I knew I had like some function. So for that, yeah, I don't like the source is the bytes and the destination is the arc. Why does this arc? Oh, sure. That's why. No, we need the destination is arc. No, arc. So are we all right here? The arc. Okay, let's get better name. Target arc. And we have the target arc as bytes. Target bytes. And the source is the target bytes. And voila, we have the. Do we compile? Do we run? No, but this should be fine. We don't need that. This is fixed in the other. We don't need that info stuff. Okay. And I think now we should be ready to implementing the echo dam. Okay, I didn't expect that. Let's quickly. We have a deadlock somewhere. Okay, we're doing the sys execute. We have the process with lock. Oh, we're in the closure. Okay, sure. Uh-huh. And we're in the start program 107, which is in scheduler. So we're getting the log of the process table. And somehow this log is already taken. But who has all the CPUs are currently stuck in there? Trying to get a log of the process table, but why? Like, what have we currently broke? Let's see if it runs without multiple CPUs. Okay, runs fine. Was this a single? Okay, let's enable all the logging so we see more what happens. Okay, that's a little bit too much output. So we're starting the other. We map the init process. Like all these CPUs are mapping their own. Why? I mean, we just let it run, right? Before we... Oh, I think I moved something here. We're locking the current process. But the current process should not be like we're creating a new process. And then we are in the self processes. Like, who wants the lock here? I don't. The process table is not like used very often. That's why. But we can still use our easy debugging technique and see where we get, yeah, sys execute. Something is off with this, I feel like. I don't know now what it is, but let's try self current process log get sys exec args clone. So we don't have to keep that log for such a long time. And then just do this. This works. Okay, so keeping the current process log, I think we don't get the scheduler. We should get a scheduler. And here I think we do, no, we just create a new process. We load the data, blah, blah, blah. We, ah, no, we are in the current, this is the new process. So this is not a problem. And then we cannot add it to the process table? Why should that not be possible? Like we should reproduce the same behavior if we do this, I guess. Because like I want to find out why we're stuck. So if we have a lock on the current process, and the current process is a process ref with its arc or mutex of a process, and these are independent from the process no. Like we are coming until here, I think. But not here. Mhm. Then we try to lock the process table, but what are the other CPUs doing? Like, okay, is this execute? I feel like, okay, what they do is they have the timer interrupt, then they schedule, then they say prepare next process. Then we take the process table with lock. So we're in the scheduler 139. We get the process table, or at least try to get it. Okay, but what? One CPU needs to do something else, I think. I cannot see it from here, so I have to go to all of them to look. Also preparing the next process, sorry. I mean, preparing the next, no, I think they're all doing the same. Oh no, one is doing something else. This has the log of the process table and gets the next runnable. And tries to lock this process to see if it's like runnable. Yeah, and it's trying to lock our current process. So maybe we can do like a try lock, and if it's locked, then we just ignore the process because then we skip running it. It's the option of a mutex guard. Actually, I think it's too complicated. We will change the stuff anyway. So even though we discovered a deadlock, let's just do it like this. And then just pass directly the vec so we can make use of that and avoid unnecessary copies. Because we can do not a set, but we will do like an yep, we will remove that. And we do process.set sysexec args, and we directly will do the following. We just set so we don't even like, we just move the data which we already copied. And now we should be running. What is wrong? Handler 101. F and mute. Oh, we need to do that in. Okay. Can I just use a like FN once? Or is this somewhere else a problem? No, it isn't. Nice. Okay, we can remove that lock here, sys execute, and now we can finally create the echo program after all this time. Yeah. So we will just, we go to user space, source bin, we will copy proc1, we will call it echo.rs. We will do the same thing so the LSP doesn't complain. Okay. Why is it called echo1, not echo1? Okay. And now we get the number of arcs. And for that, we get a buffer, which will be 1K, which should be plenty of data. Am I dumb? Of course. Then we can get the arc. Let's say, yeah, sys execute get arc index buff. We expect this to work. And oh, we should get return how much we wrote into the buffer. So get arc. If it succeeds, it will be use size. We don't need this info here. Get arg, which will be a u size, and we return. Actually, let's not. Let's just do it like this. And then we can do. We need to convert it to a string. So slice from. No, there's like a function. Like string. No, yeah, was in the wrong module. From UTF-8, which is the buffer from 0 to len. And we also expect command must be UTF-8. And then finally, we can print just S. And we don't use print line because, yeah, only if the argument has a print line, which does not work currently, we just print it in one go. And now space too small. What? Oh yeah, if other way around. If arg.len is kleiner than len. Because arg is the thing we pass in. Actually, I don't like, let's say that's a buffer. So then we can leave this like argument, argument, again, argument, and this is fine. And only if the buffer len is kleiner than len, source is the argument. We can do that here, don't need to do that there. Destination is the buffer. Now I bet it will work. Nice, although echo also like takes, yeah, just a space between them. So what we do is, no, we do it the space afterwards. And at the end, a new line. Very nice indeed. Cool. Okay, let's commit that. I will just commit everything and then look at GitHub what we need to change. Echo, implement simple echo version. We had to implement argument passing to processes. I'm not really satisfied with the solution because the API is crappy. However, let's leave it like that for now and improve in the future. So I guess, yeah, the next video will be about improving that, or we do something else, like I'm just, decide from time to time what I want to do. So we can do both pull requests. Does it show up? Yes. And then quickly check through if we, left any comments or so. But actually seems quite nice and pretty clear so far. So yes, nice. This is very nice. So let's see if the checks will complete. Like I have a pipeline running automatically, which doesn't work there, but we have like check the build, we check Clippy, we check if everything is formatted, we have some unit tests. We let Miri run for a subset of the unit tests, and we have some system tests, which take some time, but like at maximum a minute or so. We can already look, see, okay, Clippy is not happy. Let's check that. Okay, we can just do arg in sesh 59. Okay, well, we do the desugaring and then, okay, sesh 62. We don't need an ampersand. Seems better. The handler doesn't need to have a return statement. I know. And we can remove some return statements. Yeah, sure, I will do what you want to do. Sys execute at arg. Sure. I guess we can also do that for here. Let's amend the previous commit and override it to see if the checks are completing. So it was only Clippy, so this should be fine. They're running again now. Should be running again now. Yes. We can rebase and merge this one for the testing stuff. Very well. And quickly wait until they succeed. We need to rebase and merge. We can automatically rebase that here. There's a conflict. What conflict is Oh yeah, we need both. Sure. Ah, okay, so keep your stress, and I'm adding the echo very well. So, okay. So there was actually a conflict. I'm sorry. Let's wait again. But yeah, that's basically it. I hope you liked this kind of video. Let me know in the comments, like I would do more. I think I need to prepare a little bit more in my head and try things out. But maybe you even enjoyed it, seeing me struggling. Could be as well. I will link it into the description so people can skip the first part if they're just interested in the functioning implementation. But yeah, it was fun for me, and I hope I see you next time. But let's quickly wait until this succeed, so you also get that dopamine shot for this successful pull request. Yeah, pretty sure Miri will succeed. Go, go, go. Yeah, all right. So thank you if you made it this far for spending time with me. And I see you next time. Bye bye.